Okay, so today we are going to cover lesson 5.3. We are going to be looking at monomial factors of polynomials. And our objective here is to cover two things. We're going to be dividing polynomials by a monomial, and we're also going to be finding monomial factors of polynomials. So two things are going to take place today. So the first thing we're going to look at is the division. So when you're asked to divide a polynomial by a monomial, and in this case the monomial is the number 5. So what I'm going to do here is I'm going to actually pull this apart, because the 5 that's in that denominator needs to divide into both of my terms. So I'm actually doing two division problems here. So when I do the first fraction, the 5m divided by 5, anything divided by itself, 5 divided by 5 is 1. So I'm left with 1m for the first fraction. And then the second fraction, I'm just going to divide 35 by 5, and my answer is 7. So my answer here is going to be the binomial m plus 7. So when we divide, we are going to divide each of the monomials by a polynomial, or each polynomial by a monomial, and then the result may be a monomial or it may be a polynomial. Now, we should always assume that the divisor, the number we're dividing by, isn't going to be 0. Now later on, we may have to figure out what numbers would make it 0. But right now we're going to assume that all of our denominators are not zeros. Let's look at another example. So here, 26uv divided by 13v. I'm writing it underneath each one. And then the subtraction sign that's in between the 26 and the 39, I'm going to put it there in between the two fractions. And now I'm going to do two different division problems. All right, so here, 26 divided by 13, I'm going to take care of the number parts. And that gives me 2 and a 1. And then I'm going to divide. There's no u to divide, so it'll stay. And then v to the first divided by v to the first, or anything divided by itself. These also become 1s. So now I'm left with 2u over 1, and I don't need to write the 1 in the denominator. Now I'm going to divide the 13v and the 39v. So 13 will go into 39 3 times. And then v divided by v is also 1. So then my final answer here is 2u minus 3. The next one is a trinomial. And again, I'm dividing it by a monomial. Now, notice my negative in the denominator. I need to remember my rules for integers. So when I'm dividing a negative by a negative, I'm going to get a positive answer. So here I'm going to rewrite it, and I'm going to put that negative 3x squared under each one. So 3x to the 4th, and then in the denominator I'm going to put negative 3x squared, and then 9x to the 3rd y, and it gets the negative 3x squared, and then the 6x squared y squared. So now I'm going to divide each one. So the first one, when I divide it, 3 divided by negative 3 is negative 1. So here, if I simplify this, I'm left with a negative 1 there. And then x to the 4th divided by x squared is just going to give me x squared left in the top. And then when I divide negative 1 by x squared, I just get a negative x squared. Next, I'm going to divide negative 9 and negative 3. This is actually going to give me a positive 3. And then when I divide my x's, x to the 3rd divided by x squared just leaves me with one x in the top, and then the y. So the next term is going to be 3xy. Next, I'm going to divide positive 6 and negative 3, and I get 2. And then x squared divided by x squared is 1, and then the y squared. So then I'm left with 2y squared, and that was negative because it's a positive divided by a negative. So let's try the next one, and again I'm going to pull it apart and write each one. So x to the third y, and in the denominator I'm going to put in xy. And then 4x, and then xy in the denominator, then 6y, and then xy in the denominator. So now I need to divide each one of these. And again, I'm going to subtract the exponents, because remember this xy, they all have an assumed 1 there. So x to the third divided by x to the first, I subtract, and I get x squared. And then y to the first minus, or divided by y to the first, is going to be just 1. So this becomes 1s. This is gone. This will change to a 2. The next term, when I divide, there's a assumed 1 here. So this becomes negative 4. Notice my x's become 1s. And then the y is left in the denominator. And then the next one, I can again simplify the y's, and then this time there's an x left in the denominator. Remember, if you're subtracting those exponents, if you get a negative exponent when you subtract, or a negative number, it needs to be written in the denominator. Everybody good on that one? Okay, let's try another. Now let's go ahead and take a look at the factoring. This is what we're going to do next. So what we're doing here is, if you read this, it says we say that one polynomial is evenly divisible or just divisible by another polynomial if the quotient, so the answer to the division problem, is also a polynomial. So we're going to be dividing, and that's what we did on the other example. And this time what we're going to do is, after we factor something, it's going to sort of look like a distributive property problem. So what we're going to do is, you're going to be given an expression. Instead of like last night's homework where you were just given two numbers and asked to find the GCF, now what we're going to do is take the expression that they're asking us to factor. So the 5x squared plus 10x, and we're going to look for the greatest common factor of the two terms. And if it's got a plus sign, I'm going to treat that as a positive 10. If it's a subtraction sign, I would treat it as a negative 10. So I need to find my greatest common factor of these two terms. And my greatest common factor between 5 and 10 is going to be 5. And then the greatest common factor out of the variable part is, I'm going to look for the smallest one, and it's going to be the letter x. So my greatest common factor for these two terms is going to be 5x. I'm now going to take that greatest common factor, and I'm going to divide both of my terms by it. So just like we did in the previous examples, I'm now turning this into a division problem. I now take the GCF that I found. It gets written on the outside of the parentheses, and in the parentheses is going to be the answer to my division problem. So when I divide 5 by 5, I get 1s, and then x squared divided by x is just going to leave me with an x. Then for when I divide the 10x by 5x, this is going to give me 2. So the way to check your answers is to make sure that the number outside of the parentheses is the GCF, and if it is, we can distribute this, and if it goes back to our original, then we know we have factored it correctly. So when I distribute 5x to x, I do get 5x squared, and 5x to 2 gives me 10x. So it does check out. The answer to my problem is this, 5x and then a parenthesis x plus 2. Let's try example 6. So for example 6, we have 4x to the 5th minus 6x to the 3rd plus 14x. I need to find the greatest common factor between these three terms. Now, first I'm going to look at the coefficients. So out of the three numbers, 4, 6, and 14, what is going to be my greatest common factor? 2. Okay, so 2 is the GCF for the coefficients. And then from the variables, notice they all have the letter X. So when they all have the same letter in common, that's going to be the letter in my greatest common factor, but I need to find the smallest exponent, which is going to be just the X. So now I'm going to take that GCF and divide each one of my terms by it.
Mr. Colgrove, your 7:30 appointment is in the main office. Mr. Colgrove.
Okay, so now I'm going to divide each of the terms. The answer to each one of my division is going to go in the parentheses. So when I divide 4x to the 5th divided by 2x, 4 divided by 2 is 2. And then when I subtract these powers, I'm left with x to the 4th. So 2x to the 4th. Then I'm going to shift to the middle term. And I'm going to divide -6 by +2, which will give me -3. And then I can subtract my powers here. X to the 3rd divided by x to the 1st gives me x squared. And then lastly, 14 divided by 2 gives me 7. And then x to the 1st divided by x to the 1st is 1. And again, the way that you can check this is to distribute it. 2x to the 2x to the 4th should give you 4x to the 5th. 2x to the 3x squared. And 2x to the 7. And it did go back to the original, so I did do this correctly. Now, let's say you did not pull out the correct GCF, and there was still something you could factor further. That could be your catch. On the next example, I'm going to show you how a common mistake might occur. So let's look at example 7. So for example 7, 8a squared b c squared 12ab squared c squared. Okay, so let's find the greatest common factor here. What do you think it's going to be? 4. Now let's say you didn't realize it was 4 and you pulled 2 out. Okay, if I pull 2 out, it's not going to be fully factored. So make sure that you're double checking that it's going to be the greatest. So watch what happens if I try dividing these by 2. If I divide this by 2, just the number part, I would get a 4 here, and then here I would get a 6. Notice if you look at these, you could still pull out another GCF. Does that make sense? So if after you divide, if you look at your numbers and it looks like you can still make them smaller by pulling out another GCF, you need to go back and rework your problem. But let's go ahead and do this problem with the correct GCF. So you said the GCF for the coefficient part, you told me it was 4. Do they have any letters in common? Yes. Okay. What letter do they have in common? Do they both have A's? okay? And we look for the smallest one, which is just the plain letter A. Do they both have B's? Yes. And again, I look for the smaller exponent. And then for the letter C, notice they both have a C squared. Okay, back to this. So, all right. So I'm going to divide each of them by 4A, B, C squared. The answer to the division here is 2. And then nothing else. I'm going to divide negative 12 by 4 is 3. And then the A's cancel. I'm left with a B. The C's cancel. Now, don't get, yes, they're canceling, but you need to remember that a 1 is left behind here. And then here the B, 2 minus 1 is 1. And then here that was the 3. Same thing here, 2. This is gone and gone. Now, you can again distribute this back. If it does not go back to your original problem, then you need to go back and redo it. Does that make sense? All right, let's see. And that is the end. Let me do one more of each. Let me do a division, and then I'll do one of the oral exercises. Then I'm going to give you back your test, and we're going to go over it. So for example, here on number 3, I would write the 4u divided by 2, 6v divided by 2. This will give me 2u, and then 3v. When it says to factor, I would look for the greatest common factor between 6 and 9, and that would be 3. Notice they don't both have the letter P, but they both do have the letter Q. So my GCF is going to be 3Q. I like to write the GCF under each one, so I get a nice little visual here to see what I'm dividing by. So here, I'm going to divide it, and I get 2P, and then here I get 3, the Q's go away, and then the R. So that is factoring and dividing these polynomials by a monomial. So your homework is 2 through 54 even. And what we're going to do now is I'm going to give you back your test, and we're going to go over the answers.